Yes, chapter 4, moving charges and magnetism. We have completed every theory and most of illustrations and exercise. In last lecture of chapter number 4, we will discuss some questions from exercise. See, exercise question number 4.6. A wire having length 3 meter and carrying current I is equal to 10 ampere is placed inside solenoid perpendicular to its axis. Magnetic field inside solenoid B is equal to 0.27 Tesla. You have to find what is magnetic force on wire. See, if I draw solenoid, it is solenoid. Suppose current flowing from solenoid is in this direction, then yes, uniform magnetic field, it is in this direction. Okay. Now a wire is placed in solenoid perpendicular to its axis. Perpendicular to its axis means I can say like this. Like this. Okay. And current is flowing from here. So yes, what is force acting on wire? Force acting on wire. We know that force acting on current carrying wire, Fm is equal to IL cross V. What is its magnitude? Its magnitude is Fm is equal to ILB sin theta. Okay? I given, L given, B given, theta, you can easily say angle between I and B is theta is equal to yes, here it is 90. So what is magnetic force? Fm is equal to, it is ILB. Okay? Yes, you can easily calculate this question. Okay? So simple, you have to just understand what is given. What is given. Okay? Now, another question. Exercise 4.13. What is given? See, question A. You are given a circular coil having numbers of turns 30, radius 8 cm, current flowing from is 6 ampere. Is suspended vertically. Circular coil is suspended vertically like this. It is suspended vertically like this. Okay, this current carrying coil, circular coil, is suspended vertically, having numbers of turns. N is equal to 30, radius 8 cm, current 6 ampere. Okay, find what you have to find. What is magnitude of torque acting on it? Magnitude of torque acting on it to prevent coil from turning. What is given? See, it is suspended vertically. In magnetic field, B is equal to 1 Tesla. Field lines makes angle of 60 degree with normal. Field lines makes angle of 60 degree with normal. See, it is normal. It is normal. Field lines makes angle of 60 degree with normal. Field lines means magnetic field makes angle of 60 degree with normal. Clear about this? We know that area vector of circular coil or area vector is always perpendicular. Area vector is always perpendicular. So yes, if it is normal, it is nothing but area vector. It is nothing but area vector. Your question is find field lines. If field lines makes angle of 60 degree with normal to coil, find magnitude of torque acting to prevent this coil. What is torque? Torque equation. Yes, you know equation of torque. Torque acting on current carrying coil. Tau is equal to, it is M cross B is equal to MD sin theta. Okay, yes, it is tau is equal to, it is M cross B, or is equal to, I can write MIA cross B. Okay, now its magnitude tau is equal to, it is NIAB sin theta. NIAB sin theta. You are given value of N. Yes. You are given value of I. Yes. A. How to find A? Yes, I can find A. See. And I. A means circular coil, so it is pi r square. B sin theta. Pi r square, here it is B sin theta. Clear about this? Yes. N is given. Yes. I is given. Pi you know. R is given. Yes, you have to convert this radius in meter. Okay. B, yes, it is also given. Magnetic field is given. Theta, what is angle between A and B? So yes, theta is equal to here 60. Theta is equal to here 60. So yes, each and every value is given. You have to calculate this. You have to calculate this. Clear about this? Second question. What is question B? What is question B? If circular coil is replaced by a planar coil of same area but irregular shape, see what is equation of torque and numbers of turn. I pi r square b sin theta. In this equation it is n I a. A means area. A means area. If area is same but it is irregular, then yes, from this equation we can say torque will be same. Torque will be same. So yes, if circular coil is replaced by another irregular shape, but having same area. Answer is unchanged. Clear about this? So yes, two simple questions. Yes, see, question is long, but its solution is very easy. You have to just remember equations. Chapter 4, exercise, illustrations, very simple, because you have to just remember equations. Which equation you have to use. Now we will see some more questions. Now, exercise 4.25. See, you are given a circular coil. Total number of turns 20, radius 10 centimeter, and you have to convert it in meter, is equal to 0.1 meter. Carrying current 5 ampere is placed in magnetic field B is equal to 0.1 Tesla. Normal to plane of coil. How to draw figure? See, if it is coil, okay, magnetic field is normal to plane of coil, means like this. It is magnetic field. Also, yes, what is area vector? Area vector is also normal to plane. So yes, area vector is also in this direction. Yes or no? Yes. So yes, normal to plane means what is angle between A and B? So here I can say angle between A and B is A and B. What is angle between them? Yes, it is 0. It is 0. Yes, I will write theta is equal to 0. Theta is equal to 0. First question, what is total torque acting on coil? Yes, we know equation of torque. Torque is equal to it is M cross B, or I can write N I A cross B. How to write its magnitude? Tau is equal to it is N I. Where is I? Yes, here it is I. A B sine 0. You know what is value of sine 0? Yes, 0. So torque is equal to 0. Clear about this? Okay. Now, what is total force on the coil? Remember, students, in chapter 1 we have discussed one point: behavior of electric dipole in uniform electric field. Whenever electric field is uniform, means at each and every point value of electric field is constant, so total force on electric dipole is 0. We have obtained one relation between current carrying coil. Current carrying coil behaves as magnetic dipole. So yes, again, if we compare, we can write as on electric dipole, in electric field, uniform electric field, total force is 0. Then in uniform magnetic field, on magnetic dipole, total force is 0. So yes, here we have to remember, in uniform magnetic field, in uniform magnetic field. Force, total force is always zero. Is always zero. Clear about this? So yes, total force sigma F is equal to 0. Remember this point. Okay. In a uniform magnetic field, total force is always 0. Now, question C. What is question C? See, average force on each electron when area of cross section of this ring, is 10 raised to minus 5 meter square, and number density of electrons is 10 raised to 29 meter. Each electron. Now see, in this wire, in this circular coil, current is flowing. Current is flowing means charges are flowing, means electrons are flowing. Yes or no? So yes, I can say these electrons are moving in magnetic field. These electrons are moving in magnetic field. And what is force acting on electron? Force acting on electrons in magnetic field. In magnetic field. What is equation? F is equal to Q V cross B. What is its magnitude? F is equal to Q V B. Yes, I will replace this Q by E. E V B sine. What is angle? What is angle? See, it is circular coil. Magnetic field is perpendicular to this coil. Obviously, it is circle like this. So charges will flow like this, charges will flow like this, yes or no? And magnetic field is perpendicular to it. So what is angle between velocity and magnetic field? It is obviously 90. So yes, F is equal to, it is EVB because sin 90 is 1. Clear about this? Now you are given what is value of E 1.6 into 10 to minus 19. B, magnetic field. What is magnetic field? Yes, it is 0.1 Tesla. B is equal to 0.1 Tesla. But you are not given speed of electrons. You are not given speed of electrons. Then how to find the speed of electrons? See here, this side. You know one equation. Chapter 3. Remember, I is equal to NQAVD. Yes or no? Or we can simply write V, where what is V? Drift velocity. What is V? Drift velocity. Again remember equation. I is equal to NQAV. I is equal to NQAV. The relation between drift velocity and current density. Okay. So yes, I is equal to NQAV. Yes, I can also write this equation as I is equal to NEAV. Why E? Because electron is flowing and charge of electron is fundamental charge 1.6 into 10 to minus 19. Okay, I have to find V. So V is equal to it is I upon NEA. I is equal to it is V is equal to it is I upon NEA. So simple. E, here it is E. What is V? It is I upon NEA, and here it is V. You are given each and every value. E cut. I, what is current flowing? Yes, here it is 5 ampere. B, magnetic field 0.1 Tesla. Number density, yes, you are given. Area, yes, you are given. You can easily find this question. Clear about this? So yes, once you draw figure, once you write data, what you have to find? You have to find force acting on electron. Electron is moving in magnetic field. So yes, that is only one equation. So you have to think from this equation. F is equal to Q V cross V is equal to E V B sin 90. E V B. E is given, V is given. You are not given V. Then see data N. This N suggests which equation you have to use. Clear about this? So be clear about equations. Okay, I'll suggest one. Okay, make one notebook only for formulas. Chapter 1 formulas, chapter 2 formulas, chapter 3 formulas. Then whenever you solve MCQs on such questions, you can link between such questions or some questions. Clear about this? Okay. Now next question, exercise 4.26. Now next question, exercise 4.26. See, yes, data. See it is. One solenoid having length 60 centimeter, radius 4 centimeter, having 3 layers, each having 300 turns. Okay. In this solenoid, a wire having length 2 centimeter and mass 2.5 gram lies inside solenoid normal to its axis. Normal to its axis. Okay, both in horizontal plane. Current flowing from wire is 6 ampere. You have to find what is current flowing from solenoid to support weight of wire. Now see, first of all we will draw figure. Here it is. Here it is. It is solenoid. It is its axis. Suppose current flowing from solenoid IS, it is in this direction. Okay, so magnetic field B in solenoid is like this. Okay, wire lies inside solenoid normal to axis, but both in horizontal plane. What is meaning of horizontal plane, students? This wire is placed like this, like this. Do you understand? See, lies inside the solenoid normal to axis. Yes, it is normal to axis. See, it makes angle 90. In horizontal plane means like this. In horizontal plane means like this. Clear about this? Okay. So yes, I will draw that wire like this. Okay. It is placed like this. Clear about this? Okay. Now, what is current flowing from wire? It is IW. It is IW. It is given 6 ampere. What is your question? Question is 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 equal to what? To support weight of wire. To support weight of wire. Weight, that is mg of wire, it is always acting in vertically downward direction. It is always acting in vertically downward direction. So yes, current flowing from solenoid must be such that magnetic field produced must be such that force acting on this current carrying wire due to solenoid acts in upward direction. Acts in upward direction. Acts in upward direction. Clear about this? If current flowing from this wire, it is in this direction, it is IW. Then see, from figure you can say current flowing, it is in this direction, magnetic field this direction. So force acting on wire due to solenoid, it is in upward direction. It is in upward direction. Clear about this? Clear about this? Okay. Now how to solve this? How to solve this? First of all, current flowing from solenoid is IS. So magnetic field in solenoid. Magnetic field inside solenoid. Inside solenoid. B is equal to, we know equation is mu 0 Ni. It is mu 0 Ni. Or I can say this mu 0 Ni as mu 0 N upon L. N upon L. Is. Clear about this? Mu 0, 4 pi into 10 raised to minus 7, you know. Number of turns, see here it is. 3 layers having each 300 turns. 3 layers having each 300 turns means total numbers of turns. Total numbers of turns n is equal to, it is 3 into 300 is equal to, it is 900. Is equal to, it is 900. Clear about this? So yes, mu 0 you know, and you know, length of solenoid you know, Is, that is current flowing from solenoid, that we have to find. Clear about this? Now due to this magnetic field, what is force acting on current carrying wire? Due to magnetic field, force acting on wire, that is Fm is equal to, yes, what is equation? Fm is equal to IL cross B. But I, what is current flowing from wire? It is IW. So here I will write IW. Clear about this? L, yes, length of wire is L. B, that is magnetic field. How to write its magnitude? Fm is equal to IWLB. See, lies inside solenoid normal to axis. Magnetic field is in this direction. Current flowing from wire, it is in this direction. What is angle between them? 90. So yes, here it is sin 90. Here it is sin 90. Clear about this? What is value of sin 90? Yes, it is 1. So here Fm is equal to IWLB. Yes, here it is B. It is mu 0 n upon S Is. Okay, so it is magnetic force acting on wire. Upward direction, mg in downward direction. What is your question? Find value of Is to support weight of wire. To support weight of wire, it means mg is equal to Fm. mg is equal to Fm. So mg is equal to, what is equation of Fm? I W L mu 0 n Is upon here it is length of solid. Clear about this? Clear about this? You are given each and every value. M, mass of wire 2.5 gram, we have to convert in kg. G, 9.8. IW, what is current flowing from wire. L, length of wire, you are given. Mu 0, 4.2 10 to minus 7. Total numbers of turns, 3 layers, 300 turns, so it is 900. Length of solenoid, L. Current flowing from solenoid, you have to find each and every value is given. You have to just find what is value of Is. Clear? So yes, see students, if you understand solution is simple. Find Fm, then it is equal to Fm. But you have to understand question. Okay, what is given? What is figure? Clear about this? Yes, I think you can easily calculate this question. And yes, if you have any doubt, contact me. Okay, watch regular videos. With this, chapter 4 is over. And now, from next lecture, we will start chapter 5. That is magnetism and matters. Okay, watch videos regularly, make notes regularly, and yes, you have to prepare for each and every exam on Monday, Wednesday, and Friday. Plus, do comment, like, and share our videos.